second here. There we go. So let's show you what it's about. We are going to find a technique to find the area between two curves. So I want to imagine we've got a curve y equals f of x. We've got another one called, say, y equals g of x. Maybe we want to find the area from A to B. Maybe we want to find the area where A is where they intersect and B is where they intersect again. Whatever way it's phrased, we're essentially wanting to find the shaded area here. And the good news is, well, I think it's good news, that the formula, the method that you use, is pretty straightforward. Do you notice it's an integral? That's not a surprise. Starting in this case at x equals a and finishing at x equals b. And all you do is you find f of x, take away g of x. Logically, does that seem sensible? If you want the area between two things, you probably subtract two things. So intuitively, it doesn't look that weird. Couple of points before we actually get into the nitty-gritty of applying this is that this answer, this area, is a physical area, right? So it's not like an area under a curve where you could have 0, negative, or positive, and all three are fine. This is actually a physical area. So we're now back to this answer must always be positive.
What?
I'm going to pause this a minute.
Okay.
And I'm going to mute people for obvious reasons. We don't need your personal conversations. Okay, so you'll have to hit space bar if you want to say something. So where was I? So this answer here better be positive. If you ever do the area between two curves and the answer ends up being negative something or 0, you've done something wrong and you have to go looking for it. So far, so good. Area between two curves. So I have set up a little hit list of how we're going to approach this. So how to find the area between two curves. So here's my question to do it to. Let's suppose we're being asked to find the area between this quadratic curve and this straight line. Essentially, you can break the question into 4 major steps. Step 1 is pretty much draw the two curves on the same diagram. Desmos is how I'm going to do it because that's really good, but TI-84 does a job as well if you don't want to have to load up your computer all the time. Once we've done that, we're going to find the points where they intersect, x equals a and x equals b, or we might just be told that x is 5 and x is 7, in which case that step's trivial. Step 3, from your picture, identify who f of x is, because f of x isn't just arbitrary. F of x is actually the top, the furthest up, and the g of x is the one that's lowest down. You'll very often see in some textbooks that they make a little vertical rectangle, like this guy, just randomly in the shape. And f of x is the curve that's highest up, and g of x is the one that's lowest down. So if you ever see a picture with a little rectangle in it, that's what that's about. Now, once you've identified who the f of x and the g of x is, you basically integrate, and that is it. So let's show you us going through this question. So first thing I'm going to do is I'm going to find, excuse me, I'm going to find Desmos. Where are you hiding, Desmos? I know you're here. You here? Huh. Can never find things when I want them. Is it here? No. I must have closed it. Okay, try that again. Okay. I'll use the screen. Okay. Are you looking at WebAssign right now? Okay. So let's set up what you would do, we are going to use Desmos. So I'm going to hit canvas because I can. And I'm going to pick our class, which in my schedule is this one. Then I'm going to go to student view. So this is kind of what your canvas would look like, right? And I believe it's under resources and down at the bottom, Desmos. Desmos is basically just an online site, but it's very good for what it does. So our two curves in the question I just gave you, you type in y equals 4x, take away x, and if you hit that little guy down there, you could use that button if you want for x squared, and then you hit enter. And hey, that's pretty cool, right? And then the second curve was y equals x. And they even do it in color, which I like. And if you put your pointer over the picture and hit the left button, you can even move things around a little bit, and you can make it bigger and smaller, and you can play about with it to your heart's content. So there we go. Let me zoom in a little bit on this one. There we go. Nothing too surprising. So that is step one. Find the coordinates of the point of intersection. Well, you see this guy here? Would you agree that's definitely x equals 0, the origin? And if I click on this guy, do you see its coordinates are 3, 3? So do you know how Desmos identifies them? So what does that tell me? It tells me that the curve starts at x equals 0 and it finishes at 3. So the area between the curve is this piece here. You see it? So, hey, is that not going to make your life so much easier and colorful? Because you get colors and it tells you a lot of cool stuff. So I'm now going to stop sharing that. I'm going to return back to our original question with all its steps. And you don't need to do this bit, but this is just me doing it visually for you. That was basically our straight line. And then we had another guy that looked like that. This fella in here was x equals 3. This guy was x equals 0. And there's our guy. And this fella is going to be the f of x.
Professor, we can't see your work.
Sorry? Oh, you can't see it. Oh, God, sorry. Thank you for telling me. There we go. So there's the little sketch that you had in Desmos. X equals 0 is here. X equals 3 was there. This is the top curve. This is the bottom curve. I've basically got step 1 and 2 and 3 done. You see the top guy and the bottom guy? If I put one of those little rectangles in, if you are one of those kind of people that need emphasis, can you see that the 4x minus x squared is the high up one and the y equals x is the low down one? So the area between these two curves is going to be the integral from 0 to 3 of f of x, which is that guy, take away g of x, which is that guy. And next line, 0 to 3, 3x take away x squared. Use a power rule on that, so add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, evaluated at 0 and at 3. So I get 3 over 2 times 3 squared times 1/3 times 3 cubed. Take away a whole load of nothing, so I'll just write nothing down. That's going to be 27 over 2. Take away 9, which is what, 18 over 2, which leaves me with 9 over 2. So I now have the area between those two curves. It's 4.5 or 9 over 2. Any questions about that process? Are we okay? It's positive, good sign that I didn't screw up. Now, here's a little algebra issue. And let's suppose that we want to find this fella.
Can I see the piece of paper for 10 seconds?
Suppose this was f of x, and this was take away g of x. Right. In fact, I don't really care about these numbers. Okay. So, what do you want to do here? What is the mistake? I am now about to do a deliberate mistake. What is wrong?
The +1 should be a -1.
Right. So when you're doing the f of x take away g of x, will you emphasize it with brackets? Right. And will you make sure that you subtract both terms? Seems quite trivial, but it's surprisingly how easy that is. So never write down x squared take away 3x minus 5x plus 1 dx. If what you really meant was that guy, take away that guy. You see how it makes a big difference. It's a trivial mistake, but let's emphasize it now. That way you'll not do it in the future. Okay. Have we any questions again? Seem pretty straightforward, at least what you've seen. Right. Let's look at another question then. Never find things when I want them. There we go. Okay. So, just opening up our homework. Well, I thought I had earlier, but for some reason I lost it. Okay, here's a version of question 2. And we are going to be working with the area between y equals e to the x and y equals x to the 6. And we're being told that we only want the area from 0 to 1. Right, so e to the x, y equals x to 6, 0 to 1. So we know we're going to set up an area here. The fact that it's 0 to 1 makes life relatively easy. So let's see what that looks like in Desmos. Okay, get rid of these two guys. And I have y equals e to the x. And that's not right. I have y equals I should be okay then. Okay. E to the power of x. There, I gotcha. Let's try to find out whether it needed a specific e, which it doesn't. And the other one is x to the 6. There we go. We're also interested in what x equals 0. And we're interested in x equals 1. This picture's getting a bit messy. Let's just zoom in on it. The green line is e to the x. This purple curve is x to the 6. And we're doing it from x equals 0, which is here, to x equals 1 is here. So the answer to the area that we're trying to find between the two curves is this piece in here. Can you visualize it? Because I can't shade it in. Right, it's this area in here. Which one of them is going to be f of x? E to the x or y equals x to the 6? Which one of them is going to be the f of x?
Y equals E to the X.
Agreed. How do you know that?
Well, for the shaded area, it's the top curve.
That's exactly what it is. Okay. Let's turn to my notes. I wish there was a quicker way of doing this. Somebody who's doing Zoom should have a one button. You know, you hit E and you go one screen, you hit F, you go the other screen. Wouldn't that make my life so much easier? Somebody should think about doing that. Okay, so we got, there's my f of x. Take away my g of x. That's a very crude example of what we're doing. Right, it's that little piece in there. Right, e to the x, antiderivative e to the x, power rule for the other one. Evaluated at x equals 0 to x equals 1 in this case, so we don't need to worry about intersections, but if we did, we could certainly use Desmos to find them. So it's e to the 1. I'm just going to call that a 7 because it really is. Take away e to the no minus 0. So what do I have? E, take away 1/7, take away 1. I'm going to have e minus 8/7. And we want to know the exact answer. So that is your exact answer. Are we good? Still comfortable? Nothing too strange has happened? This is your chance. I believe, I'm not 100% sure, but I believe WebAssign has a little hiccup that we have to fix. So let's go back to here. Let's go in here. I don't want that. No, I don't want that. Okay, area between curves. I want that. No, I don't want that. Darn it, my brain today. I have to do student view because if I did, go away. If I did it the other way, I don't think I'd be able to show you what I want to show you. Okay, here we go. Right, this one here is essentially the question we just finished a moment ago. And the answer was E take away 8/7. So I'm going to click on that. And I'm going to go E, subtract, and I should be able to do 8/7 without too much trouble. And that's that guy. And now I'm going to try submit answer because I'm worried that it won't accept E, which was just E on the keyboard. And it didn't. So I'm going to fix that. I'm going to go over here and I'm going to go hunting for E, and I think I passed it. You see E? I'm going to put E to the power of 1 and submit answer. No. Did I screw up in my calculation?
Professor,
Yes.
this problem though on your website is saying y equals x to the 4th, so that's a different problem.
Oh, a different problem. Ah, shooting space. That's because WebAssign keeps randomizing the little darlings, don't they? So, you know, okay, now that shouldn't take me too long. What would the answer be? It'll still be E, but I'll get a 5th and a 5th. So what will I get? I'll get 1/5. I'll get I think it's going to be 6/5. Okay, let's try that. Okay, we are good. WebAssign will accept the letter E on your keyboard. I was worried that it wouldn't. Oh, wait a minute. Didn't I just fix that? Ah, shooting space. Let me check that out. This is E on the keyboard. I've not done any shots. Oh, you're fine. Okay, not a big issue. That's good. E on the keyboard is fine. You do not need to go down here, hit that guy and pick that E, right? That makes life a little bit easier. Next question then. Get something in the chat, anything? Right, someone has told us that E is fine, but when you have to do the cosine, sine, or tangent, you have to go to that calc pad and pick sine, cosine, and tangent. You can't just type in SIN like on a keyboard. Has anybody found that out when they did WebAssign? That you have to find the sign button, not type in SIN.
WebAssign will let me type in SIN just fine.
Same here.
It auto converts. It's the nicest thing.
Okay, so life is easier than I thought. So
Sometimes it gets really picky about where the exponent for sine and cosine and such is, but it works.
Oh, you mean like sine squared?
Yeah, one
Yeah,
sine
versus
squared
sine
to
x squared. Yeah.
Right, so you have to put sine x in a big bracket and square it. Is that what you're saying?
No, you just have to fiddle with the arrow buttons.
Oh God, right. I'm glad it's you and not me. Okay, where was I? I was in the middle, hearing good stuff and then got confused. Okay. For speed purposes, you are not going to see me zoom into Desmos, back out to Desmos, and then do a type. So you're just going to, what's the word? You're just going to believe what I'm about to show you, right? So here is an example of question 5 where I'm adding in an extra problem. We're being asked to find the area between this cubic and a nice straight line. And you're going to trust me on this part. But when you do Desmos, it will look something like this. And if it doesn't look perfect for you, just pretend I can draw better, right? That's what x cubed take away 15x looks like. Nothing too surprising about that, I'm sure. You could probably guess it would look like that. Just bring this down a little bit. And then you had the straight line y equals x, and we can pretend that the green, the straight line y equals x looks like that. Now we're being asked to find the area between these two curves. There is a problem with this question. I'm going to shade in what they mean by the area between the two curves.
Would the area be 0?
It would be 0 if you just did the integral, but I did say at the start, this is a physical area. So that means your answer must be a number, a real number for this area and this area together. So what that means, in fact, is that we have to split this into two distinct situations. Right. That guy is at 0. Can you trust me that this guy is at 4 and this guy over here, right, is at -4? So what do I mean by splitting into two areas? Let's call this guy here A, just for argument's sake. If I wanted to find the area of A, wouldn't it be the integral from x equals 0 to x equals 4? Would you agree that the straight line, the green line, is higher than the red line? So that makes f of x take away g of x dx, and put a big bracket. Are you happy with that as the setup to get A? Are we good on that? Are you comfortable with that? That's how you would find A. Can't see. Actually, Maury, you should put your video on. That would make my life so much easier, because then I could see you and I'd know. I'm kind of out in the ether on my own here. I feel like I'm alone. Let's see if I can get some of you. Okay, I got some pictures now. Okay, are we good with that as the setup for A? Right. Now, what about B? Let's call this guy B. Now, remember, I'm interested in the physical area, right? So it's going to be the integral from -4 to 0. In area B, do you see it's the red curve that's higher than the green curve? Do you see the top to bottom? What does that look like? Well, it looks like this. That guy first, take away that guy second. Do you see that what you need to do then is basically two separate integrals that you then add up? Now, someone at the beginning said, will the answer be 0? If you just did, well, it doesn't really matter who you pick first, but if you did this guy, take away that guy, but you did it from -4 to 4, the A and the B would cancel out, and the answer to the integral that I've just written would be 0. But that integral does not represent the area between these two curves. Isn't it the addition of A and B that represents that? Are you comfortable with that?
Would you be able to find the integral of one of them and multiply it by 2 if it's symmetrical?
You are. I'm doing telepathy right now, because that's exactly what my next sentence was going to be. In this shape, would you agree that there's a lot of symmetry going on? What you're saying is, look, if I got A, couldn't I just double it and that would be the answer? And your answer, and yes, is the short answer. Now, if the shape is asymmetric, can you imagine there was a little bump here, but a really big bump there? We wouldn't be able to do that, find one and double it. Would you agree in this second picture? That just won't make sense. But in, there we go. There we go. Cool with that? I guess I should do one. I'll do A because I'll set it up that way. The integral from 0 to 4 of x take away x cubed minus 15x. Let's take care of this bracket issue. That's an x, take away an x cubed, add 15x. That becomes an x, how many x? 16x, take away x cubed. Just do power roll on it. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. That's going to be a bit messy, but I'll try it. 8 times 4 squared times 1/4 times 4 cubed. Take away a whole load of nothings. 4, 16, 64, 128. Take away 64. Come on, you should be impressed by that. I did that in my head. That's scary. Shouldn't we check it? Let's check it. Y equals x, take away, put a bracket around it, x cubed, subtract 15x. Do a window from 0 to 4. Do a zoom 0. Okay. Do a second calc, number 7. Start at 0. Finish at 4. And I want to see 64 when this is finished. Oh, come on. Am I good or am I good? Eight o'clock on a Monday morning, and I can still occasionally get the right answer. That cheers me up a lot. Oh, you might have noticed that the shape looked nothing like the original picture. It's not meant to. Isn't this integral actually a different function than that guy? Right. So if you were wondering why it doesn't, that's because it's not. Are we good? Try something else on the calculator before we leave this. I got a y equals x, and we have an x cubed. Take away 15. We're going to do a zoom to fit. Okay. Might not look quite like the picture, but that's the accurate. I'm now going to go second calc, choose number 7. I'm going to do from 0 to 4. Yeah, that didn't work. Oh, of course it didn't work. It's x cubed take away 15x. That's why it didn't work. Zoom 0. Okay, that looks a little bit more like the picture. Second calc, number 7. Lower limit 0, upper limit 4. Yeah. And unfortunately, it doesn't do it. Yeah, was worth a try. I was wondering to see if TI-84 would actually do it, but it isn't that clever. Okay, see, we got another one to look at. What's the time? Ah, God, I'm slow. This is a version of question 6. We have a curve called y equals x squared, which is pretty easy to sketch. We have a straight line, 8 minus 2x. We have another straight line. I'm going to show the colors here. Black. Y equals 2x add 16. We are being asked to find this area. Now, this point here has an x coordinate of 1. This point here has an x coordinate of 2. And this point here has an x coordinate of -2. Pretty much I've given you everything on this picture that you need to find this area. But your first thought should be, but there's 3 equations and I only need an f of x and a g of x, and then I subtract them, right? So we have to figure out a strategy for finding this total area. But the trick to doing it is to realize that you don't find the area in one go. You break the shape up into, in this case, 2 pieces. And then you find the area of each piece and add them. Where would be a natural place to split this shape? At what
X
value of
equals 1.
x? Agreed. Would you agree that would be a really helpful place to split that shape? Now I'm going to call this guy A again, and I'm going to call this guy over here B. So let's find A. A is this area here, right? On the right-hand side. X starts at 1 and finishes at 2. So that's how I got that. Now I need an f of x and I need a g of x. Right? I need a top curve, I need a bottom curve. What's the top curve?
The top curve is 8 minus 2x.
Okay, it's the green straight line. Would you agree that the bottom then is that guy? And you've got A. But how about B? Let's switch attention over to this side. Now it's going to go starting at x is -2 and finishing at 1. What is the top curve or line? It could be either. What's the top function?
Two x minus 16.
Okay. That was plus 16, but I know what you meant. And the curve is x squared. Now, if you're looking at that and you're saying, I can, you know, what's that phrase? You can't see the forest of the trees, right? There's so much stuff going on there that I can't focus on what you're talking about. Let's look at B for a moment. The only thing I'm interested in is in this shape. So if you draw one of those pretend random rectangles, right? They're just invisible, but you kind of write them down. Can you see that the straight line is the top guy and the curve is the bottom? The straight line is this fella, right? And the curve is this fella. That's where they came from. So when you're finding the area between the two curves and they're orientated this way, shouldn't you be thinking a top guy, take away bottom guy, right? Highest curve, take away bottom curve. For the piece of the area that you're interested in. Now, if there's only one continuous area, that's easy. But if you have to break it into two shapes, doesn't the thing change because of that? I'm not going to do these two. You could do them. Would you agree? The integration part of these questions has not been the problem. I mean, haven't there been power rules and e to the x? Have been nothing really too weird and distracting. See if I can find a trig one to do. I'll have to make this one the last one for today. This is a version of question 9. There's one of the curves. There's the second curve. And here's a vertical line. So if I go into Desmos and I do 5 over x, it'll look something like this guy. If I do, actually, I'll make him 5 over x squared. And if I do the other one, 5 over x, he looks a bit like this guy. And if I do x equals 6, it's about here. Now, there's a point of intersection, that point. And if you go to Desmos, can you trust me, it tells you 1. So the area between the two curves we're looking for looks a bit like a banana to me. Would you agree? It's kind of banana shape. So now I should be able to set up the integral. Would you agree in this question, it's a lot simpler than the previous two? Isn't it just one guy in the top all the time, the same guy, one guy in the bottom, always the same guy? You agree? Red guy on top, blue guy on bottom. So red guy, take away blue guy. That's my f of x. That's my take away my g of x. This guy I got from Desmos was an x is 1. This was given to us essentially in the question, so that's where that came from. I like 5 over x, so I'm not going to do anything to 5 over x. Any suggestions about a better way to write 5 over x squared if I'm going to integrate it?
5x to the -2.
And that's so we can use the power rule. Great. So what do I get? I get 5 natural log of x's, add 1 to the power and divide by the new power. Gets me that. And that becomes 5 log x style points, which gets me to here. And I get 5 log 6 plus 5, 6. Take away 5 log 1, add 5 over 1. I'm not going to do anything about 5 log 6 or about that guy. What number is 5 times a natural log of 1?
Isn't it 0?
Yeah. So all you get is take away 5. For style points, do you think that's the best that answer can be? You happy with leaving that, or could you do something better?
Maybe the fraction and the whole number.
Okay, let's do that then. That turns into 30, that eventually gets you -25, 6, and that is it. Can I fix 5 log 6? Not really. I guess I could call it the natural log of 6 to the power of 5, but that's just as ugly as 5 log 6, so I'm not going to change it. And we are finished for today. Will you remember to say